Okay.
Hello, everyone. This is Professor Richard Chung with Department of Chemical and Materials Engineering at San Jose State University. How are you doing? Today, I'd like to welcome you officially to San Jose State University, and I would like to share with you three important things related to material engineering at San Jose State. One, I want to share with you the field of materials engineering. And second, I would like to share with you how much work needed to get there in order to get a degree in Bachelor of Science in Materials Engineering. And third, what kind of jobs and what kind of job markets are there. So upon your graduation, you'll be able to enter the workforce. As you probably know, material engineering program has been around since 1958. And San Jose State is known for one of the oldest universities in the California State University system. And San Jose State is located in the center of Silicon Valley, surrounded by 6,000 companies. The population in the city of San Jose is around 1 million and is 10th largest city in the United States. The climate is wonderful, and we have a lot of diversity and different ethnic background people around this area. The technology-wide, because it's located in the Silicon Valley, the technology is vibrant and are very dynamic as technology develops. And so the university have to keep the pace. Also, at the campus, we have a lot of fun because not too far from beach and mountains. As you can see, university, a lot of colors, beautiful trees, and nicely done campus. A lot of beautiful scenery here, there. And based on the US Bureau of Labor Statistics, it defines the occupation of materials engineering and its salary. So basically, the material engineers will do manufacturing of materials or use materials for future engineering applications. The material used are composite materials, a combination of various materials, metal and metal alloys, ceramics and glass, plastics and polymers. And one of the materials which is not listed here, which also combines many materials mentioned above, that is semiconductor and electronic devices. Believe it or not, Bay Area is the #1 hire for material engineers. And similarly, state of California is also #1 hire for materials engineers. So based on the statistics, if you go to the link below, you'll be able to find out the hourly rate in average is about $51. The mean annual salary is about $107,000. The majority of people in the category of 75 to 90% percentile are making between $57 to $71 an hour and $120 to $148,000 a year. The statistics also show that different regions are making different wages and salaries, and California is on top, as I mentioned earlier. So what does a material engineer do? Basically, is to cultivate engineering expertise from your chemistry, physics, math, and integrate them into your knowledge. With that, you will be able to solve engineering problems and solve the global issues. So material engineering is truly an interdisciplinary field in that it covers life sciences, physics, chemistry, and mathematics. Almost every product in different industry can be made out of materials, such as biotissue organs, medical devices like implants, semiconductor electronic devices, biomimetics materials, automobiles, electronic devices. Almost anything you can think of can be made of materials. Materials also help civil and other fields to build tall buildings. And without material, they would not have the construction material to resist high wind, structural integrity, and maybe earthquake-related damage. Similarly, as you can see, the tall building in Dubai, they can sustain the height and with the structure properties. Recently, people are very interested in additive manufacturing, also known as 3D printing. In 3D printing business, you can print almost anything you like to print, including skulls and other tissue and organs. Even buildings, cars can be made out of 3D printer and different configurations as well, including bicycles, recreation goods, and cookie printers, something like that can also be done. In space, which is the area that a lot of parts, when they get damaged or broken, they cannot be repaired easily, and they rely on the supply from the Earth. And with the 3D printer, you can print the parts right there in the space, and that could solve the problem. Again, the materials, the printing technology all relate to the field of materials engineering. And similarly, in space exploration here. In Silicon Valley, and also along with many companies in the world, big and small, they all require material engineering to help them to accomplish their goals. So some of the companies making drones, making some special missions require strong and lightweight, and also other materials to achieve the goal. And as you can see, that company after companies are doing that. And if you sign up for material engineering, what kind of jobs you will be doing, and for your profession, there will be something like energy, solar, battery, water, computing, you name it. I mean, there are so many different fields you can enter. So material engineering is not limited to one field of industry. Recently, we are very unfortunate running into the COVID-19 pandemic situation. And as you can see from the headline here, Apple Computer is able to quickly transition into a face shields producer, even though they are good at the computer related or iPad, iPhone, that kind of business, but now they are able to use the same type of engineers to help them make face shields that's material related. Similarly, Bloom Energy, a fuel cell company, is able to tackle the problems for all ventilators for the state of California. So as you can see, that material engineers are flexible, versatile, and are able to quickly turn around and use their knowledge and experience to solve problems. So when you sign up for material engineering at San Jose State, you will be asked to do a lot of work. No pain, no gain, as you know. But also, we want you to have fun. So we have advanced technology, state-of-the-art equipment here, which will enable you to see nanoscale materials and supercomputing material simulation. We also want you to have fun making some materials you like to make. So how do you get a degree in materials engineering? The university requires a student to have 120 units, which could be broken down into 3 major categories. One is general education requirement. The second one is the major, which requires the science background, like chemistry, physics, and math. And also the 68 units allocated to junior and senior level classes. When you are at the junior, senior level, you'll be seeing your advisor periodically, almost every semester, to work on your study plan until your graduation. So you are on track, you are guided, so that will save your energy. Here is some of the courses on the left-hand side, square here. Some courses that are very interesting, useful to material engineering students. For example, the top scanning electron microscope, which is a lab class. When you do the hands-on work on this equipment, you'll be able to see some of the nanowires in the range of 10 microns can be seen easily using the scanning electron microscope. A student will have hands-on experience in many courses here, including 154, 141, and many others. Now, toward the end of the education, you'll be working on a senior design project, which is a capstone class. This class will assess your ability to enter the workforce before your graduation. So what is the objective of this course? This class will ask material engineering students to show their understanding of material engineering principles to design and implementation of an approved material project. And in that project design, students will have to integrate global and social issues into the product. And this senior design project will last for 1 year, starting from fall until spring. And so it's a lot of work in that. And this will kind of prepare students to tackle on real world projects. And so a lot of students have no experience, have never done that before. So how to succeed in this 1 year long capstone class? So don't worry, we have a lot of helpers here. You will have academic advisors who help you and coach you. Similarly, we have technical advisors from different disciplines and sometimes from industry. And we have student club where we have students in similar majors and get together, work out the problems. And we also have technical professionals from professional societies such as the ASM, SPE, SAMPE, and various organizations in the material engineering arena. Those people have experience and knowledge. They will come in to help you. Students can also choose industry-sponsored project if they know a company they like to work with, and we try to collaborate with them, such as in the next few slides, I'll show you the company names. And internship opportunities. If you got recruited by a company, you could also use the internship projects. Currently, I have a student working on internship project at NASA Ames because of turning into the senior project. Another big advantage of this program is that this program has been around since 1958. So we have a lot of graduated alumni who reside in the Bay Area. They serve as a big support to the program. So we also have alum support. Like I have coached a couple of students who graduated 4 or 5 years ago. Now they are working in industry. Now they come back to help the current student on senior project. Similarly, we are student help. So based on my experience, nobody failed the senior project before. This just showed a few company names here, like EAG has been a big supporter, NASA Ames, Jabil Technology, Western Digital, Thermal Fusion, Hewlett-Packard, SRI, Lam Research. I mean, you name it, many companies have contributed their workforce as technical advisors, also sometimes support the material purchase and project ideas. We enjoy to work with them as our partners. So this slide shows an example. On the top picture here, you can see our student presenters are in front here and also in the back. The one in the back is our former alum, who is now a professor at Chico State, who came back to help students here. And these are all professionals here to help. student, and Professor Kalish and myself also witnessed the student presentations at the company called Exponent. Bottom two pictures here on the left is the student team who just finished competition in San Diego during the 2020 TMS conference, who compete with other universities in student project competition. Likewise, we also have sister campus, CSU, Pomona. They also a team here, so we took a picture with them. And obviously, you can tell we also have collaboration and exchange ideas and our experiences in the competition and projects. Because of COVID-19 virus pandemic situation, we are not allowed to be on campus. Here we just show you a few major labs. We have more than 4. Just major lab to walk you through what they're doing here. So on the upper left corner here, lithography lab, which is a big lab, 3 rooms embedded in here. You could do dissection, grinding, polishing, and then you could also do microscopy. And in that, you'll be able to reveal the fingerprint of a material. Upper right corner, this is a lab which is huge, that we have so many undergraduate students working on lithium battery research. At the lower left corner, this lab has a lot of mechanical testers. We could do the tension, impact, harness, and also do electrical measurements. The bottom right here shows we have a scanning electron microscope and also X-ray diffractometer in the back. Both can reveal material at the micro to nano range. So anything we cannot see by naked eyes, we can use those equipment to help reveal the features and properties. Just show you a few topics that we conduct in the department here. We have 5 full-time material engineering faculty members, including myself. Many of us have experience and knowledge in the topics we conducted. I'm actually working on water-related, water filtration, membrane technology. Professor O working on batteries, and Professor Gleisner working on semiconductor electronic devices. And Professor Kalish work on sports and also machine vision, machine learning, virtual reality, big data, those very advanced technologies. Professor Casey work on computational research, including simulation analysis. So to give you some examples, I'm showing you one of my research work. I have a few students working on water filtration in the range of ultra filtration and nano filtration range. In that, we use carbon nanotubes, which is about 5 nanometers in the diameter here, and put them in a vertical way and put a polymer on top, trim top and bottom, and we make a membrane. This membrane will allow us to remove the contamination in the water, and hopefully we could have drinkable water one step. So as you can see that during the work, still able to study the material structure using the optical microscope, using scanning electron microscope. And this is another view of using scanning electron microscope to see 20 micron range. And we also have atomic force microscopy, which enable you to reveal the surface profile, like a surface roughness. In this case, it's only micron range, but it could go down to nanometer range. The membrane we produce could be put into the tennis balls to prevent air leakage. So the tennis balls can stay inflated for more than 2 or 3 weeks, or maybe even longer. Similarly, the membrane put into the tire to make a tire inflated forever. Using their technology, we could also do other things, such as use different chemical structures. Attaching to medicines, we'll be able to do drug cell delivery in the bioengineering field. That's also materials engineering's specialty. And we could do gas sensing, such as putting some sensors embedded in the material. When gas molecule going through, they will have a reaction. So you'll be able to see what type of gas is going through. And this is schematics drawing showing how we put the molecules in between to check gas molecules. Oh, yeah, so we could also use silicone plate with silk cocoon to develop bioorgans. Our materials also able to do artificial limbs to help those disabled people. In fact, sometimes the performance is even better than the normal person. Material oftentimes kind of surprise people. And so these are some examples of old days when they use material to make artificial limbs. Now, current days, we use more advanced materials. And a not dislocated shoulder can also be put into the reality if we can use material to make it help a patient to recover. In the sports field, people like racing cars, which has to be high performance, high speed, lightweight, and impact resistance. So in case of there's an accident or something, we also have to design the car to prevent the driver from injury. So as you can see in the next slide, unfortunately, this person, the driver is injured. But because of material, he did not get a fatal injury, just minor cuts. So material, in fact, is another way to help people to achieve the additional destination. Materials are also used in the civil engineering field, like a retrofit a pipe to repair the corroded pipes. In some sense, also prevent from leaking or additional soil slide or earthquake movement because material is stronger than other original pipe. So you can see here, we have different type of pipes, different type of materials involved here. And at some point, if you need to build a light bridge and able to be able to function and quickly done and with beautiful eye-catching configuration, material can make it happen. Material also can sustain in such a way that a quick bridge can have the tank go over it. Stealth bomber, stealth fighter, they are invisible to radar screens. And so the material engineer have put some electronic energy absorption material in there. And so that even though they are physically flying in the sky, but they will not be detected. UAV, unmanned aerial vehicles, they are flying around the globe 24/7, and they also need to have some special type of material to prevent from being shut down, and also could be sustainable with fuel efficiency and high performance. In the battlefield, we have different material used in the defense vehicles. In the commercial goods, commercial vehicles like Airbus 380, Boeing 787 Dreamliners, these are all have high performance commercial jets, and they not only have good performance, fuel efficient, but they also are beautiful inside out. As you can see that the seats inside are beautiful. For speedboats, they are traveling at 200 to 250 miles an hour on open water. And you can see that there's a lot of challenge to the driver, and material engineer also have to protect their cockpits. In addition, material engineering will enable a lot of patience in terms of their personal parts or any personal needs. For additional sports area, you not only have your own equipment, you have the only color or only type of material you can choose from. And so not only the performance, you could also show off of your skateboard, snowboards that nobody have, because it can be custom made. With all this, I thought, I'm pretty sure I have convinced you to sign up for material engineering. And I hope that you feel the information presented is useful to you. In case you still have questions, please sign up at 10 a.m. on April the 18th, so that you have a live person to chat with you to answer your questions. And I hope you enjoy the presentation, and I do hope to see you enrolled in class in fall 2020. This is Professor Richard Chung, and I have my email list again here for you in case you want to send your questions to me. And thank you for listening, and have a nice day. Stay healthy. Bye-bye.